Hey students, in this video we're going to discuss hyperbolas, the last conic section. So a hyperbola is a graph that has two branches, and it's a set of points where the distance from one point on the opposite branch to a focus is the same as if you take another point on the other branch and go to the other focus. So say we'll call this point A, then we'll draw another point here called point B. So the distance that we travel from B to F1 and the distance that we travel from A to F2, so we'll put arrows to indicate, right? So if we subtract these differences, if we subtract these distances, we're going to get the same value as if we did this with, let's draw another couple of points. So say I'll put another point here, another point here. So we'll call this point C, and we call this point D. So if we draw from C over to this distance, to this focus, and from D over to this focus, whatever this distance is, we'll call this distance W, we'll call this distance X, and then we'll call the distance from A to focus 2, we'll call that Z, and we'll call the distance from B to focus 1 R. So a hyperbola has this property where the absolute value of Z minus R is going to equal the absolute value of W minus X. When you subtract any two distances of points, you're going to get the same fixed value. That's what makes it a hyperbola. So it's not that the points are the same distance away from anything. It's that any 2 points, when you subtract them, you get the same distance for a hyperbola. So the parts of a hyperbola are called a branch. In this case, we have a horizontal hyperbola because the branches open up left and right. The center of the hyperbola is this line, is the midpoint of this line segment called the transverse axis. And we can see the transverse axis in this diagram where here's our transverse axis. The center is the midpoint of the transverse axis. And the vertices are the points on the hyperbola that intersect the transverse axis. Perpendicular to the transverse axis, we have this other axis called the conjugate axis. And it's going to have an equation of x equals or y equals, depending on which way the hyperbola opens. The diagonals of a hyperbola are used to help draw the parabola. I mean, not parabola, I'm sorry. They're used to draw the hyperbola, and they happen to be the diagonals of this guide rectangle. The guide rectangle has a width and a length that are equal to the length of the transverse axis and the width of the conjugate axis. And so that's how we make our rectangle. We're going to need that to draw our hyperbolas. So did I miss anything here? Yeah, that's about it. We have this equation. If we have a horizontal hyperbola, the x is going to come first, and we're going to subtract the y. If we have a vertical hyperbola, you're going to subtract the x. The y is going to be positive, the x is going to be negative. And when we get our foci, c is going to equal the square root of a squared plus b squared. And to get to your foci, you're going to add and subtract from one of the center coordinates. If you have a horizontal hyperbola, you're going to use that c value and change the x value. If you have a vertical hyperbola, you're going to use that c value and change your y coordinate. And the slopes of the asymptotes are going to be b divided by a. And we can write the equation of the asymptotes by using the point slope formula. Remember, the asymptotes have to go through the center of the hyperbola. So for example 1, we're going to graph the hyperbola x minus 2 squared divided by 9 and y minus 3 squared divided by 16, that equals 1. So straight out, we see that a squared is equal to 9. So a equals 3. And b squared equals 16. So b equals 4. Okay. Our center, let's write this. So our center is 2, 3. So we're going to go over 2 up 3. This is the center of our hyperbola. So our transverse axis, because A is with the x, and always with the x, mind you, A is always with the x. So since the x is positive, our transverse axis is dictated by the x. So we're going from the center, we're going to go right 3 and left 3. So we're going to go 1, 2, 3. This is, we'll say vertex 2, then 1, 2, 3 left is going to give us vertex 1. And then so our transverse axis is right here. That's our transverse axis. It's 6 units wide. The conjugate axis is going to go through x equals 2. Let's write that. We can write that. So the conjugate axis is x equals 2, and our transverse axis is y equals 3. So it's just going to be y equals the coordinate for the y coordinate, and x equals the x coordinate for the center. So to get the rectangle from the center, we need to use our b value to go up 4. So we're going to go up 1, 2, 3, 4, and go down 1, 2, 3, 4. So now we have this nice rectangle that is going to help us draw our hyperbola. And from here, all we need to know is our focus. Even though they're not going to help us draw the graph, we can plot the foci as well. So c is going to equal the square root of a squared plus b squared. So c is equal to the square root of 9 plus 16, which of course is the square root of 25, which is 5. So from the center, we're going to go 5, which means we go 1, 2, 3, 4, 5. So we'll say our second focus is here. And then just from the other focus, we need the other vertex, we can just go 2. So our 2 foci are at, so we'll say F1 has a coordinate of -3, +3, and then F2 has a coordinate of 7, 3. All right. So we have our foci plotted, our vertices plotted, and now we need to draw our asymptotes. So the equation for our asymptotes, the lines have to go through the center. So we know the slope is plus and minus b divided by a. So the slope of one of the asymptotes is b is 4, a is 3. So the slope is 4/3 for one and -4/3 for the other. So one equation is going to be y, remember the point slope formula, y minus y0 equals m times x minus x0. Cool. So in this case, y0 and x0 are the coordinates of the center. So y minus 3 is going to equal 4/3 times x minus 2. That's one of our lines, and the other one is y minus 3 equals -4/3 times x minus 2. So same thing, just one slope is positive, the other is negative. And if we draw that, just remember we can just from here we can actually just go up 1, 2, 3, 4 and over 1, 2, 3. But if we need the equations, we have them. So right now we're graphing a positive 4/3 x minus 2 one, and it's going to look something like this. And then our other, you know what, I actually should do these in dashed lines because they're asymptotes. So let's draw it like that. Instead, let me take out part of, so we'll make it a dashed line so that it looks like an asymptote. All right, so we have our asymptotes. And next, the last part is you draw the curved part of the hyperbola, just so that, you know what, let's draw a rectangle in a different color too. So we'll put the rectangle in red so that we can differentiate it between that and our hyperbola. So let's draw the hyperbola in green. So then you just get very close to the asymptotes. Get very close, but never touch. And it looks something like this. Not a perfect drawing, but illustrates the point. And that is how you draw a hyperbola by hand. You draw your guide rectangle, you plot your vertices, plot your foci, you graph your asymptotes, and that is it. It's exactly the same thing if we have a vertical hyperbola, except everything is going to open up and down instead. So for number 2, we need to find the equation described by the hyperbola. In this case, we're going to have to complete the square. So let's group all of our terms first. We're going to have 9x squared minus 54x. And then we're going to have negative 25y squared minus 50y. And we're going to move that 169 to the other side. So immediately we know our parabola opens left and right because the x is positive. So now we've done completing the square for every section and conic section. So we should be pretty good at this by now. So first we factor out a 9. We're going to get 9 times x squared minus 6x. So half of negative 6 is negative 3, and negative 3 squared is 9. So we're going to do plus 9. So we haven't added 9. Remember, we've added 9 times 9. So we've added 81. So we get 169 plus 81. That is 250. And so then we also can factor out a negative 25. So minus 25. That's going to be y squared minus 2y. So then half of negative 2 is negative 1. And negative 1 squared is positive 1. So what we've actually added is negative 25 to both sides because we have a negative 25 times that 1. So that's going to give us a negative 25, which means we need to subtract 25 on the right side. So on the left, we get 9 times x minus 3 squared minus 25 times y minus 1 squared is equal to, so that's 250 minus 25, which is 225. Now our next step is going to be to divide by 225. And conveniently, when we do that, we get x minus 3 squared. So 9 over 225 reduces to be 1 over 25. And negative 25 divided by 225 conveniently reduces to be 1 over 9. So we're going to get x minus 3 squared over 25 minus y minus 1 squared over 9. And that's going to equal 1 because, again, we divided everything by 225. So the next thing, now we need to find our center. That's straightforward. The center is 3, 1. And then our vertices. So we know A equals, A is going to equal the square root of 25 or 5. So our vertices are 5 away from the center. So we'll say V1 is 8, 1, and V2 is negative 2, 1. Cool. And then, so we found we did our center, we did our vertices. The focus. So for the focus, we need C. So C is going to equal the square root of 25 plus 9, which is the square root of 34. So focus 1 is, so from our center, we need to add the square root of 34. So 3 plus the square root of 34, 1. And the second focus is 3 minus the square root of 34, 1. And since we're not graphing this, you don't have to give me a decimal or anything. You can give me the exact value. So that's our foci. Our transverse axis is the horizontal line that goes through the center. So we'll call our transverse axis is y equals 1. The conjugate axis is x equals 3. And last is the equation of our asymptotes. So let's scroll a little bit. So the slope of either asymptote is plus or minus b divided by a. So the slope is 3 plus or minus 3/5. So the equations are going to be, so the equations of our asymptotes are y minus 1 equals, we'll just say plus and minus 3/5 times x minus 3. And that's as far as we need to go. This is going to give us 2 asymptotes, and that's all we need to do. All right, so from here, on this problem, we completed the square. And from there, we did everything that we did in example 1. We got our center, we got our vertices, we have our foci, we did the slope, we have our transverse and conjugate axis, and we use the slopes to find the equation of each asymptote. So for our last example, we're just doing what we did in the other sections. If you're given different information, you should be able to write the equation. So if we're given the vertex of 0, 1 and 8, 1 and a focus of 11, 1, we need to write the equation. So let's get a rough sketch of how our hyperbola looks. So 0, 1 is right here. Let's say that I'm sorry, that's not true. That is not where 0, 1 is. 0, 1 is going to be on the y-axis, excuse me. So 0, 1 is here, and 8, 1 we'll say is over here. You go over 8 and you go up 1. So let's flesh that out. So since those are our vertex points, the center of the hyperbola is going to be the midpoint between 0, 1 and 8, 1. I'm pretty sure you can deduce then that our center has a coordinate of 4, 1. So right now, because one vertex is to the left and the other is to the right, we know our hyperbola opens left and right. So that means that x comes first. So we have x minus 4 squared divided by a squared minus y minus 1 squared divided by b squared is equal to 1. The other thing that we know is that the focus is 11, 1. So let's plot the focus in some other color. Let's go with, we'll just go with black. So like even further down, you have a focus of 11, 1. So the focal distance, or C, is the distance from the focus to the center. So in that case, 11 minus 4 is 1. 11 minus 4 is 7. So C is equal to 7. Now, by our formula, we know that C should equal the square root of a squared plus b squared. Now, we also know that A is 4 because the distance from the center to one of the vertices is either A or B, depending on which way the hyperbola opens. So since our hyperbola opens left and right, then this value here is going to be A. So we also know that A is equal to 4. Then to solve for B, so 7 is going to equal the square root of 16 plus, 7 is equal to the square root of 16 plus b squared. If we square both sides, we get 49 equals 16 plus b squared. and we subtract 16 to get 33, and we take the square root, we get the square root of 33 is equal to b. Now, really, all we need to know is what b squared is, because that's what we need for our formula. So we would get x minus 4 squared divided by 16 minus y minus 1 squared divided by 33 is equal to 1. So here again, that 49 equals 16 plus b squared implies that 33 is equal to b squared. And that's all we need for our equation. For letter B, we have a vertex of negative 10, 5, and an asymptote of negative 1/2 times x minus 6 plus 5. So if we write this in point slope form, we get y minus 5 is equal to negative 1/2 times x minus 6. Remember, the asymptotes go through the center, and so what we know from this is that the center is 6, 5. Great. And so if the center is 6, 5, then the distance from the center to one of our vertices is the A or B value. So again, the y coordinate is the same. Those two things are equal, which again means our hyperbola opens left and right. So A is going to equal 6 minus negative 10. The distance between those 2 points, that's going to be 16. So A is 16. Now remember, the slope of the asymptotes are plus and minus b divided by a. So what we know is that b divided by a without the plus and minus is just going to be b divided by a equals 1/2. Now we know a is 16, so that's going to imply that b divided by 16 equals 1/2. And obviously, if we multiply both sides by 16, we're going to get b equals 8. Okay, so now we have our center, we have our a and b value, so we can write our equation. So x minus 6 squared divided by 16 squared, which is 256, and then minus y minus 5 squared divided by 8 squared, which is 64, that should equal 1. So we used our asymptotes to find the center. We used the equation of the asymptote to find the center. And once we had the center, we could subtract the difference between the appropriate coordinate and the vertex coordinate and get our A or B value. In this case, it was A. And so A was 16. And once we knew that A was 16, we know the slope is always b divided by a, and so we substitute in the appropriate value to find the missing variable. In this case, that was b. And so last is, if you're given vertices of 3, 2, and 13, 2, and the endpoints of the conjugate axis are 8, 4, and 8, 0, we need to write the equation. You know what? Just so we can be different and switch this up, because everything has been left and right, say that's, actually, let's go back for a moment. And so let's make some changes so that we get something slightly different. So everything's not dictated by the x's. So instead of 3, 2, let's make it 2, 3. And instead of 13, 2, let's make it 2, 13. And then instead of the endpoints of the conjugate axis, make it the endpoints of the transverse axis. Are still... So we'll need to switch these around to be, you know what, actually, let's not make any changes. I don't want to blow this up, so I don't want to throw everything off. So let's just go with it as is, and we'll do more examples in class with the y's instead. So if our vertices are 3, 2, and 13, 2. So 3, 2, we'll say is like right here. And then 13, 2 way down the line is like right here. Cool. So again, the center is just the midpoint. So we can, again, probably easily determine that the center is 8, 2 using the midpoint formula. And what we know is the conjugate axis has endpoints of 8, 4, and 8, 0. So let's say 8, 4 is right here. So that's our point 8, 4, and then 8, 0. Right, I didn't draw this well, but nobody's perfect. So 8, 0. Now the B value in this case, because our hyperbola is going to open left and right again, the B value is half the length of the conjugate axis. So the conjugate axis has a length of 4, so that's going to mean that B equals 2. A is going to equal the distance from the center to one of the vertex points, so A is going to equal 5. So now if we write our equation, we have our center, we have our vertex, we have our center, we have our A and B values, so we're going to get x minus 8 squared divided by 25 minus y minus 2 squared divided by 4 is equal to 1. And from here, you should be able to get all of the relevant information, the foci, the transverse and conjugate axes, the equations of the asymptotes, and you should also be able to graph it from here. All right, so that concludes our video for hyperbolas. Pretty straightforward process. We are, again, just using completing the square to put the things in the standard form and parsing our formulas and equations to get the appropriate information. Hope the video was helpful. See y'all.